Very kind. Yes. All right. It's absolutely fine. Okay, so 2.7, I need to unfreeze the screen there. Sorry about that. There we go. Okay. 2.7 is distances and midpoints. All right, so some information for us today. Given 2 points, you can draw a right triangle. That's the symbol for a triangle. And use the Pythagorean theorem to find the distance between the points. Okay, so just a second. Okay, so we can use the Pythagorean theorem to find the distance between the points. So horizontal, right? So our leg A is going to be x squared, the absolute value of x squared minus x1. And our vertical leg is going to be the y squared minus y1. So look at the diagram that we have there. It's kind of hard to see. You might have to outline it. So these are our 2 points. Okay, given 2 points, you can draw a right triangle. So we're going to draw the right triangle. We're just going to connect these points. Okay, and you can see that says side A or leg A and leg B. Can you see that in your diagram? Okay.
I can see it now
that I drew it. Okay, so then this is point P over here, and this is point X1, Y1. So it's our X value and our Y value. This one, okay, has a different X value. It's X2, but it has the same Y value, Y1, because we stayed on that Y, that same Y, and moved over. And the point at the top is an X2 and a Y2 value. Okay, because from that Y2, we just went straight up and we stayed on that same X this time as that one.
So it's X1, Y1, X2, Y1, because you have to stay on the same
horizontal line.
Uh-huh.
Yep, because that time we stay on the same vertical as what we had. So that same X value we stayed on to make the vertical line. You got it. Okay, so the distance formula then is D, the distance, okay, between any 2 points, P1, which is X1 and Y1, those are the coordinates, and P2, the X2 and Y2 coordinates, is given by this formula. So you need to memorize this formula. Okay, so it's the square root of the change in X squared plus the change in the Y's squared. Okay, we're going to apply it to make it make some more sense. So in example 1, it says find the distance between -4,2 and 1,7. And it says substitute the points into the formula and solve. That's all we're doing. So D is going to equal the square root. What are my X values? Remember it's X1 or it's XY.
So your X values are 1 and 4.
So 1 minus -4 squared, so I need to square it, plus what are my Y values?
Y values are 7.
So 7 minus 2 squared. And order matters. And you did great because we started over here. Yeah, it's the same thing as the other formula, the slope formula.
So, yeah,
yep.
For the X's, if you said 1 and then -4, but for the Y's, could you do 2 and then 7, or do you have to stick with the other left or right?
You have to keep the same order. You can do 1 minus 4, 7 minus 2 like you did, or you could do -4 minus 1, and then 2 minus 7.
So you have to, if you go left to right, you have to do left to right on the Y as well.
Okay. Yep. Good. Good question. You always have to keep the same order. All right, so let's check this out. What's 1 minus -4? 5. So this is going to be 5 squared. Plus, what's 7 minus 2?
So you square after you do that.
Yes, we do parentheses first. Order of operations says parentheses and then exponents. Yep, so it's the square root of 25 plus 25. So the square root of 50. Okay. And so can you, without a calculator, tell me about that, right? Okay, so it's going to be 5 times 10. Okay, so I wrote the 5. Okay. Okay, so you jump to the answer, but we in our warm-up we kind of talked about, so it was 5 times 10, which is 5 times 2, 5 times 2, which Ethan is right, that is 5 times the square root of 2. All right, but go ahead and put it in your calculator and let's get a decimal form it. But see, we're going to put some wavy lines and say that's approximately what number? Yep, the square root of 50. It's approximately, give me to the thousandths place, or sorry, the hundredths place. Okay, so that's the difference. That's okay, the hundredths. So here's the difference. When we have a decimal, we have to use, it's approximately 7.07. If we actually use the radical sign, it is actually equal. That is the exact answer. Okay, so a little bit of difference there. But so is the equation, that distance equation, too terrible? No, we have some good practice with it, with using slope. Yeah, just a matter of remembering what it is. Okay.
A lot of the times I can do the math, it's just figuring out which math to do.
Yeah, this is true. Okay, then we have the midpoint formula. Okay, so this is the midpoint of a segment connecting P1 and P2. So if we want to find the middle of a segment, like here, we're going to use this formula. So the midpoint, that capital M, to find our x value, we're just going to average them. We're going to add them and divide by 2. And to find the y value, the same thing. We add our y values and we divide it in 2. And that will give us the midpoint, because the midpoint's the middle or the average. So again, let's try it. Find the midpoint of the segment with endpoints -3, 4, and 1, 9. So the midpoint for our x, we're going to find the average of our x's. -3 plus 1 divided by 2, and that's a comma in there. And then what's the average of our y's? Okay, divided by 2. Okay, so what's -3 plus 1? So we've got -2 over 2, comma, 4 plus 9? 13 over 2. Okay, and so we're going to reduce this. What's -2 over 2? -1, comma, 13 over 2. Okay, so 6.5 or 6.5. So our midpoint would be -1, and then 1, 2, 3, 4, 5, 6.5. Right there it is. That's the midpoint, which means, you know, that this side of my segment is now equal to that side of my segment, because that is M. We're not trying to draw a triangle necessarily. In the beginning, when it said you can draw a triangle, that was just to kind of help you see where we could get the midpoint formula or the distance formula from and things. We're not actually drawing a...
So the point is we're just finding the distance between 2 points.
Correct. Yep. Yep. The purpose is really that we're just finding the midpoints and the distance. Okay. Good question, though. All right. So 3. Write the slope-intercept form of the equation of the perpendicular bisector of the segment in example 2. Okay, so here's the thing. What is a perpendicular? What's a bisector?
It cuts it in half, intersects it in the middle.
Intersects it in the middle. So we needed to know the midpoint so we could have a bisector. Okay, so we want to write the slope-intercept form of the equation of the perpendicular bisector. So now we know it's in the middle, so we can use that point, -1, 6.5, as one point of the bisector. But we also know it's perpendicular, so we can use that to help us find the slope. Because we know that there's a special relationship between perpendicular lines. The negative inverse. Yes, okay, or the opposite inverse. Yes. Okay, so to do that, we need to find M of the line we're given. So what is the slope of the line we're given here? So I would go from this point, I would rise how many? I would go, yeah, I would go from the, so 5 and then 4. 5 over 4. Okay. Okay. So the slope of the line is 5 over 4. Okay. And so, yes, I would go from endpoint to endpoint because they're very clearly marked. So I don't have to pick a random one in between or get the half one. Right. Okay. Fair enough. Okay. So now then, what's the slope of the perpendicular line? Negative 4 over 5. Yes. Excellent. Okay. So step 2. That's a perpendicular line. That's a symbol for perpendicular. Yes. That's the shorthand of saying the slope of the perpendicular line. Because this is the slope of this line, the one given. And so this is the slope of the perpendicular that we're writing. Good question. So now we're going to sub the slope of the perpendicular line and m, the midpoint, from example 2 into the equation. All right, so we're going to have y minus y1 equals m times the quantity x minus x1. The y1, x1, and m. Yes. And remember, this is the point, the midpoint that we're using. So we're going to plug it in. Maybe I should draw it down here to this line. So it's going to be y minus, okay, 6.5 equals negative 4/5 is my slope times the quantity x minus negative 1. All right. So that's plus 1. Perfect. All right. So I'm going to move over here when I do my next step. So I've got y minus 6.5 equals, and now I get to distribute. Minus 4/5. Good. Bobby, we good? All right, perfect. Now what do I do next? Add the 6.5 to both sides. Okay, so y equals negative 4/5 x. Okay, so this might, how are we going to do that one? Negative 4/5 plus 6.5. Oh, with a calculator. Fair enough. Okay, good. I was like,
I saw the 0.7 first and started reading it backwards.
You're good. So negative 4/5 x plus 5.7 is the equation of the line. You are okay. I get it. Okay. So how's that? That is the equation for this line. So if I drew this line, it would be perpendicular.
Oh, so we just found the equation for the perpendicular.
Yep, you got it. We've just found the equation for the perpendicular bisector. So it goes through this midpoint, and it has the slope of negative 4/5. Right? Okay. Now, I'm going to blow your mind on the back. It's true. So,
Points in space. What point is what space?
okay. So we're going to talk about this. Right. We're going to talk about this and how to solve for the distance and the length. As far as like the graphing part goes, probably not. But I do want you to realize that there are points in space. Like, I don't know, like there are several people anymore that like are interested in video gaming and things or design. And so in that case, it's taking a 2D graph and making it 3D. You got it. It's easy enough. Okay, so we can designate a point in space with an ordered triple. So instead of having an x and y coordinate pair, we're going to have an x, y, z ordered triple. Okay? All right. Okay, sounds good. And this, extend that line over that whole thing for me, please. for the distance. So we've still got the distance formula. It's the same thing, right? It's the change in our x's squared, the change in our y's squared, plus the change in our z's squared. Now, because instead of having, so we would have like 3, 2, 6 would be the order triple. 3 on the x-axis, 2 on the y-axis, and over 6 or up 6 on the z-axis. Okay. The midpoint theorem is, this, again, the exact same. We're finding the average of the x values, the y values, and the z values. So instead of doing it twice, we're going to do it 3 times. Like, because when we, yeah, for distance and midpoint, instead of just using 2, we have a third point. So, I mean, we could have a fourth point in technically in math later on. But it's pretty awesome. So we're going to do example 4. It says find the length and midpoint of the segment with endpoints 2, -1, 3, and 3, 5, -1. We're just going to plug it into the formula and do it. That part's maybe not going to blow your mind. Okay, so the distance is going to equal the square root of my x's first. What are my x's? Okay, so let's just start. So 2 minus 3 squared plus, what are my y's? So I'm going to mark them out. I did 2 and 3.
I was looking at the picture. I was like, there's no numbers.
Right, the picture's not helpful. First day.
And then you're gonna do it y's next, right?
Uh-huh.
So then you're just gonna do
-1 minus 5 squared. Okay, plus, now my z's. 3 minus -1, so that's +1. Okay, squared. Let me extend my line over there. Okay, perfect. What's 2 minus 3? -1 squared plus, no, it's -1 minus 5. -6 squared plus, what's 3 plus 1?
4. I can do that one.
4 squared. Woohoo! All right, now square root. What's -1 squared? -1 times -1 is a positive 1. Good try.
Which that's how I think.
I know. What's -6 squared?
-6 squared is
36. And what's 4 squared?
16. Yeah.
16. Okay. So now we have the square root of 1 plus 36 plus 16.
36, 37, and then that's
Plus 1? No, you didn't. 6 plus 6 was 12.
Hold on. Let me get this.
52 plus 1. You got it.
Oh, yeah.
53. Okay. Okay, and give me the approximation in your calculator, if you want. 7.28. Okay. Because 53 is actually a prime number, so that would be it. The square root of 53, or approximately 7.28. Okay, perfect. You just found, oh, let me put that. You just found the distance. Okay, now how long that segment is.
You don't have to find the prime thing.
No, because it's prime. It can't, nothing can be pulled out because it's a prime number. Because if it was 2, then we could find it. If it was like 52. Okay, so now we found the length, which was the distance, and now we got to find the midpoint. So M equals the sum, right? Right here, the sum of our values. And we're finding the average, I should say, not the sum. Okay, so what are the average of my x values? Okay, so 2 plus 3 divided by 2, comma, my y values. -1 plus 5 squared, and my z values. 3 plus -1. Oh, 3 plus -1. Okay, right. Okay, divided by 2. Okay, So what's 2 plus 3? So we've got 5 over 2. Negative 1 plus 5 is 4. So 4 over 2. And 3 plus 1?
2.
Oh, sorry. 3 plus negative 1 is 2. Thank you. So 2 over 2. And 3 plus negative 1? There's a negative up there. I forgot it earlier. Is that better? Negative 1. Yes. Okay. So the midpoint is, you could leave it as 5 over 2, 2, and 1. Ding, 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 ding. That is correct. That is your midpoint.
So if it doesn't divide evenly,
You can leave it in fraction form, or you could write it as 2.5, whichever one you are comfortable with. Or you can change it up. Sometimes you can leave it as a fraction. Sometimes you can make it a decimal. Like if I'm going to graph it, sometimes I make it a decimal. If it's a third, I never make it a decimal. I just leave it as thirds. Okay, so the next one. This is where it's really going to blow your mind. Is graphing in 3 dimensions.
No.
Okay, I promise you this will not be on the test, but I do want to kind of expose you to it a little bit. Wait, we get out at 9:45? Is that right?
Yeah.
Okay, so we just have a few minutes.
We tried to do this in geometry.
Oh, okay. All right. So, we will probably look at this a little bit more than next week because I know like time is pretty much up. But again, like one big thing here is like this is going to be a rough picture, right? This is not something that I am very good at either. It's not something that I had to do a lot of. I would rather do isometric drawings 100 times over. Isometric drawings than graphing in 3D. Like graphing in 3D is just something that's challenging, but I want you to be exposed to it. So we'll look at it a little more next week, but you can have it and kind of know that it's coming for fun. For fun, yes. Okay.
Pretty much whatever random thing he thought of that morning was what he would talk about to every class all day long.